Okay, so we're going to continue on and finish up chapter 5, and we're going to go over how to graph inequalities that have two variables. So the first thing we're going to go over is how to check if an ordered pair is a solution to an inequality. So for example, we have this inequality right here. 2x minus 3y is greater than or equal to negative 2. Now notice there's two variables, so there's not just single digit solutions. Now we are dealing with ordered pairs as solutions. So when we have an ordered pair, this represents an x and a y, we can substitute both of those values in. So I'm going to put the 0 in for the x, and I will also be putting this 0 in here for the y. And we will want to see if this makes a true statement. So 2 times 0 is 0, 3 times 0 is also 0, so we end up with 0 is greater than or equal to negative 2. Now this, of course, is a true statement, so yes, 0, 0 is a solution of this inequality. Now we can try this again for another point. So here we have 0 for the x, but this time we have a 1 for the y. Now in this situation, we end up with 0 minus 3, which is negative 3. And negative 3 is not greater than or equal to negative 2 because it's less than negative 2. So this would not be a solution. So this ordered pair, 0 and 1, is not a solution to the inequality. Then we have this point here, 2, 1. So if I want to test this point, I have 4 minus 3, which equals 1. And 1 is greater than or equal to negative 2. So yes, it is a solution of that inequality. So I just wanted to go over a few of those so you understand how to test a point to see if it is a solution or not. Because when we go to graph these linear inequalities, we can use that testing a point as one method of deciding where to shade. We can also use it to just check our work. So the steps for graphing a linear inequality, the first thing we would want to do is graph the equation. Typically, we're going to put it into that slope-intercept or that y equals mx plus b type format. After we graph the line, we will decide, do we want to make our line dashed or do we want to make it solid? So very similar to what we were doing when we were graphing inequalities that had one variable on a number line. We had an open circle if it was just a less than or a greater than, and we had the closed or filled in circle for the problems that had the equal to underneath. The same kind of concept applies here. So if we just have a less than or greater than, we're just going to use this dashed or dotted line. But if you have the equal to's underneath, then you're going to fill it all the way in and it will be a nice solid line. And then the last thing you have to do is shade on either side of that boundary line. So that boundary line, which may or may not contain solutions of the inequality, is going to separate that coordinate plane into one part that has no solutions to the inequality and the other part that contains all of the solutions to the inequality. So there's two ways of doing that. So option 1, which is actually my preferred option, is to really just look at the sign. If you have it in y equals mx plus b form, you can look at the sign. So y is greater than, or y is greater than or equal to, you would shade up the y-axis. However, on the opposite situation, if you have y is less than or equal to, you would then shade down the y-axis. And I'll explain basically what that looks like when we do a graph. Now, the other option is to use step 3 and 4 in this manner. You could pick a test point, like I just showed you in those couple examples we just did. 0, 0 is always the easiest to plug in. So if it's available, meaning it's not on the line itself, it's on one side or the other, you would see if it's a solution. If a point is a solution, then you would shade that side of the graph. If the point is not a solution because it gives you a false statement, you would shade the opposite side. You can also just use that to check to see if you shaded the correct side or not. So when we go to graph linear inequality, Before we get into those that are in this y equals mx plus b form, like example C, let's talk about just the ones that have the one variable. Now, typically, we would just graph something like this on the number line. However, in this particular example, we're looking at a coordinate plane. So we can still graph it on here, but how does this work? So if we just have an inequality without the second variable, in this case, we just have the x. This is just an x because our slope is undefined, which means we have a vertical line here. However, it is still going to be a dashed line because of the inequality sign that's here. There's no equal to on it. And x is greater, so I'll show you what that looks like in a second. So we're going to do a vertical dashed line through the point of -2 on the x-axis. Now we can't shade up and down. This is the one exception. We can't shade up or down here because it's a completely vertical line. We can only shade left and right. X is greater than -2. Well, where are the x values that are greater than -2? They are to the right. So we would shade over here to the right. Right. So that's kind of its own sort of unique kind of setup there. The rest of them are going to kind of follow a more similar pattern. Now for B, we have y is less than or equal to 1. So this is actually going to give us a horizontal line. And that's because the slope here is 0 and the y-intercept is 1. So I would go to plot my y-intercept, but then I don't have a rise or a run, so I'm just going to do a solid horizontal line. Now the reason why I picked solid was because of the equal to underneath my inequality sign. And because I have a y is less than or equal to, I'm going to shade down. So whenever y is less than, or your little symbol kind of looks like an L, less, low, I always think you're going down. So all the lesser y values are down here on the y axis, and then you just complete your shading with the rest of that coordinate plane. All right, so now we're going to get into some that are actually two variables. So we take a look at example C. It's already set up for us in the slope-intercept form. So we would want to identify our slope, which in this case would be +1, or you could put 1 over 1. And our y-intercept is +2. We can see that this is going to graph a solid line, and the y is greater than is telling me that I'm going to shade up. So when I go to put this on my graph, if you remember back from earlier chapters, we start or begin at the y-intercept, which is 2. We move in accordance with our slope, rise over run, up 1 to the right 1, up 1 to the right 1. Or you could go down and to the left. And this is going to be a solid line because of the equal to. That means that all the points on this line are not only just dividing the plane into two halves, but they're also solutions. And then y is greater than or equal to means we shade up. So you find that y-intercept, which is 2, and you shade up from there. And then once you kind of figure out, okay, I'm shading this side of the line, then you can complete the shading. Now, if you did want to do the test point, and that purpose could be to check your work or simply because maybe you just don't like looking at the sign. So if I have y is greater or equal to x plus 2, and I put in zeros for both of those variables, I get 0 is greater than or equal to 2, which is not true, which means 0, 0 is not a solution. So we would shade the other side of the line, which we did. So that confirms that we did this one correct. All right, so if we take a look at example D, my slope is 2/3. My y-intercept is -1. I can see that this is going to be a dashed or dotted line because I do not have the equal to under my inequality. And y is less than tells me I'm going to shade down. So I begin at the -1. I'm going to move up 2 and over 3, or down to left 3. I'm going to do my dashed line through there. And I'm going to shade down the y-axis. which is going to complete from there. Okay, so picking up now with example E. So once again, here we have a slope, which is always the number in front of the x, and in this case it's -2, and I'm going to put that over 1. And then I have my y-intercept, which is 3. Looking at my inequality symbol, I can see that this will be a solid boundary line because of that equal to underneath. Y is less than or equal to indicates that I'm going to shade down. So going to plot this beginning at the y-intercept, moving down 2 over 1, down 2 over 1, down 2 over 1, or up to left 1, making our solid boundary line, indicating that the points on the line are also solutions. And I'm going to shade down from this y-intercept. So I find my y-intercept and I go down, and then I complete that side of the half plane. All right, and then we're going to go to example F. Okay, so here my slope is -3/2, and I am going to put my negative on the top number. However, it can be done on either one, just not both. The y-intercept is 2. This time I'm going to have a dashed line because I do not have an equal to on my inequality sign. And since y is greater than, I'm going to shade up from that y-intercept. So beginning at the 2 on the y-axis, moving down 3 to the right 2, down 3 to the right 2, or up 3 to the left 2. My dashed line indicating that the points on the line are not solutions, and shading up from my y-intercept, and then just completing that region, filling it in. Now, if I did want to test any points here, just to show you how this would work. So for example, if I were to test 0, 0 on this graph, it should not be a solution because we shaded the other side. If I were to test 0, 0 on this graph here, it should be a solution because it is in the shaded area. If I were to test point 0, 0 on this graph here, it should not be a solution because it's not in the shaded area. And you can do that to check your work. So let's take a look at a couple graphs that are already shaded and see how to come up with our equations or inequalities. So the first thing you would want to do is find that slope and that y-intercept from looking at that line, right? So I can see that my y-intercept is +2, and it appears as if my rise over run is up 2 over 1, which would give me a slope of 2. So the equation for this line would be 2x plus 2. But since this is a solid line, I know I'm going to need my equal to. And since I shaded up, it's going to be y is greater than or equal to 2x plus 2. So let's now try it for the next one. So again here, my slope and my y-intercept. This time my y-intercept is going right through the origin, which is 0. It's a negative slope, which I can see just from the direction of, or the angle of that line, but I'm going to go down 1 over 1, so that would be a slope of -1. So far I have y equals -1x plus 0. Now this time I have a dashed line, and I'm shading down from the y-intercept, so that means I'm just going to have a y is less than, and it would just be -x because I don't need to put the 1 and I don't need to put that 0. So just y is less than -x. Okay, so now let's take a look at some scenarios where these inequalities come into play. So you have $125 to spend on school clothes. It costs $20 for a pair of pants and $15 for a shirt. Write an inequality to represent the number of pants with X and shirts with Y that you can purchase. So we have two things that we're purchasing, and we would add them together to get our total. So we would have $20 for each pair of pants plus $15 for each shirt, and hopefully that would be less than or equal to 125. Now think about it. Generally, we would write this as an equation and make it equal to 125, but in this scenario, you don't have to spend all your money, but you definitely can't spend more than what you have. So that's why it could be equal to or less than 125. Now, here's our follow-up question. Can you buy 3 pairs of pants and 5 shirts? Well, the pants are represented by X. The shirts are represented by Y. So we're essentially saying, is the point 3, 5 a solution? So we would substitute in the 3 for the X and the 5 for the Y. This would work out to give us 60 plus 75, which is 135. And that is definitely not less than or equal to 125. So no, you would not be able to buy all of those items. You would not have enough money. So another scenario. You are going to the movies. It costs $7.50 per ticket and $5 for each popcorn. You have $20 for you and your date. So $7.50 times X for each ticket plus $5 times Y for each popcorn has to be less than or equal to 20 because, again, you can't spend more than you have. Can both you and your date see the movie and have your own bucket of popcorn? Well, that would mean that you need 2 tickets and 2 popcorns. So that's what you would be substituting in for your 2 variables. So $7.50 times 2 plus 5 times 2. Well, this gives us 15 plus 10, which is 25, and 25 is not less than or equal to 20, so no, it would not work. You do not have enough money. Okay, so we're going to do a little bit more graphing here in a second, but we're going to have the problems in standard form or not slope-intercept, similar to the 2 word problems that we just worked on. So if you were doing this for a legitimate situation, you might end up with an equation that's in a form other than y equals. And in that case, you would want to get it into that y equals mx plus b form. Of course, we would be using an inequality instead of an equal sign. But the process is still the same. So if I want to get my y by itself, the first thing you need to do is add or subtract that x value to the other side. So subtracting 4x, 2y is less than or equal to negative 4x plus 8. Now whatever is being multiplied to that y, you want to divide everything by that. In this case, it's a 2. And that gives us y is less than or equal to negative 2x plus 4. So this is just a little refresher on how to get the y by itself with an inequality sign versus an equal sign. Okay, so the next example, again, we want to move the x term on the opposite side from the y, so we're going to use our inverse operation there. So now I have negative 2x plus 12. Now I'm going to divide everything by this negative 3. Y is less than, make sure you flip the sign when you divide by a negative on an inequality, positive 2/3 x minus 4. And then finally our third one, I'm moving my x over once again. I have negative y is greater than negative x plus 2. And now I'm going to divide everything by negative 1, making my y positive, but I have to flip my inequality sign, and then I get a positive x minus 2. So now let's use that rewriting the equations to graph some inequalities that are given to us in standard form. So the first one here, I'm going to move my 2x over. So now I have 3y is greater than negative 2x plus 3. And now we're going to divide everything by 3. So y is greater than negative 2/3 x plus 1. So my slope is negative 2/3 and my y-intercept is 1. So just like before now, we go to graph this. We begin at the 1, which is the y-intercept. We move down 2 to the right 3, down 2 to the right 3, or you could go up 2 to the left. It's going to be a dashed line. And because y is greater, we're going to shade up from the y-intercept which would be this half plane here. All right, so continuing on, a few more for practice. So here we're going to move the x over to the other side. We have negative y is less than negative x plus 3, dividing everything by that negative 1, which will flip the inequality sign. Our slope is positive 1, and our y-intercept is negative 3. So beginning at the negative 3, and then moving up 1 to the right 1, up 1 to the right 1. Now this inequality sign does not have the equal to underneath, so we know it's going to be a dashed boundary line. And y is greater than x minus 3, so we're shading above or up from that y-intercept. Okay, so let's take a look at our next example. Moving my 3x over to the other side by subtracting it. So I now have 2y is greater than or equal to negative 3x plus 6. And now I'm dividing everything by 2. Y is greater than or equal to negative 3 over 2x plus 3. My slope here is negative 3 over 2, and my y-intercept is 3. So I begin by plotting my y-intercept at the 3, and then I move down 3 to the right 2, down 3 to the right 2, down 3 to the right 2. This one will be a solid line because of the equal to on my inequality sign, and y is greater, so I'm going up from my y-intercept, which will be this half plane here. So we often say the boundary line will divide our coordinate plane into 2 half planes, so that's what I'm referring to there. All right, so then these next 3, I've got one more with my x and my y here. Okay, so here moving my 2x over. Negative 4y is less than or equal to negative 2x plus 4. Dividing everything by negative 4, which is going to require me to reverse the direction of that inequality sign. Negative 2 over negative 4 is 1/2 and minus 1. My slope would be positive 1/2. My y-intercept is negative 1. So when I go to graph this, I'm going to begin at my y-intercept of negative 1. I'm going to move up 1 to the right 2, up 1 to the right 2, or down and to the left. This will be a solid boundary line because of my equal to on the inequality sign. And y is greater, so I'm going to find my y-intercept and go up. Of course, for any of these, you can still pick a test point like 0, 0. In this case, 0, 0 would be a solution because it is in the shaded area. All right, the last 2 I'm going to do with you here, you'll notice that there is only one variable. So when there's only one variable, you're going to go ahead and get it by itself. In this particular problem, the reason why we have just one variable is because our slope is 0, and this is just our y-intercept of 2. So when I would go to graph this, if I begin at my 2, but I don't have anywhere to go up or over, up or to the side, it just means that I have a horizontal line, which you might remember from the beginning of the notes. Now y is greater than 2, so I'm shading up, and of course it was just that dashed or dotted line. All right, and then our very last one here. This time we only have one variable again, but it happens to be an x. So we're just going to have to get it by itself because there's really not another option. So we end up with x. I had to reverse my inequality sign, and I get a positive 2. Now this is a special situation because you're going to get a vertical line. So the slope is undefined. There is no y-intercept. You're simply going to find the 2 on the x-axis. In this case, it's a solid vertical line. So you're just going to go ahead and draw that solid vertical line. And then you're going to have to shade left or right because there's no other option. So x is greater than or equal to 2, and the numbers that are greater than or equal to 2 would be on the right side of that line. And that's how you would